This lesson will introduce you to proxies. A proxy is an object that wraps an object or a function and monitors access to it. The wrapped item is called the target. We use proxies for the intention of blocking direct access to the target function or object. The proxy object has some traps handling the access of the target. Traps are the same as the methods used in the Reflect API. Therefore, this section assumes that you are already familiar with the Reflect API, as you will use the same calls. If you need to refresh your knowledge, just jump back to the lesson before this one. You can see the traps available to you on screen. Once a trap of a proxy object is executed, we can run any code even without accessing the target. The proxy decides if it wants to provide you access to the target or handle the request on its own. The available traps allow you to monitor almost any use cases. Some behavior cannot be trapped though. For instance, we cannot tell if our object is compared to another value or wrapped by another object. We cannot tell if our object is an operand of an operator. In reality, the absence of these use cases is hardly ever problematic. We can create a proxy by calling new proxy with two arguments. The first argument is target, representing the proxied constructor function, class, or object. The second argument is an object containing traps that are executed once the proxy is used in a specific way. Let's put our knowledge into practice by proxying a target. Suppose we have a student class having a first name, last name, and an array of test scores. The averageGetter method reduces the test scores to an average value and returns it. Let's create a student called John and place 3 tests in his test scores array. We will now define a proxy on the target object John. The get method of the proxy is executed whenever we try to access a property. The above defined get trap chose to ignore all the field values of the target object to return undefined instead. Let's define a slightly more useful proxy that allows access to the averageGetter function but returns undefined for anything else. We can conclude that proxies can be used for the purpose of defining access modifiers and providing validation through the public interface of an object. The target of proxies can also be functions. For instance, you might wonder how many times the factorial function was called in the expression factorial 5. This is a natural question to ask to formulate an automated test. Let's define a proxy to find the answer out. We added a proxy that traps all the calls of the factorial method, including the recursive calls. We equate the proxy reference to the factorial reference so that all recursive function calls are proxied. The reference to the original factorial function is accessible via the target argument inside the proxy. We will now make 2 small modifications to the code. First of all, we will replace return target args with return reflect.apply target this value args. We can use the Reflect API inside proxies. There is no real reason for the replacement other than demonstrating the usage of the Reflect API. The second change is that instead of logging, we will now count the number of function calls in the num_of_calls variable. Once we execute the proxied factorial function with an argument 5 and print the number of calls, the result is printed to the console. We can also create revocable proxies using proxy.revocable. This is useful when we pass temporarily active proxies to other objects, but we want to keep a centralized control of when we want to shut them down. Let's create a payload variable and a revocable proxy on the payload. We will specify a get trap overriding default behavior. Proxy.revocable creates an object with a proxy member. This proxy member provides access to the website property of the original object using the Reflect API after console logging proxy. Once we revoke the proxy, the access rights are gone. Our code throws an error when we try using it. As both the revoke method and proxy are accessible inside revocable, we can use the ES6 shorthand notation and destructuring to shorten our code. ES6 is powerful, and this pattern keeps reoccurring in multiple places, including the module syntax of ES6. When studying proxy.revocable, we concluded that we can centralize control of data access via revocable proxies. All we need to do is pass the revocable proxy object to other consumer objects and revoke their access once we want to make data inaccessible. In exercise 1, we will build a proxy that counts the number of times a method was called. Proxies can be used in automated testing. In fact, if you read the Synon.js documentation on synonjs.org, you can see multiple use cases for proxies. You can also build a fake server for development that intercepts some API calls and answers them using static JSON files. For the API calls that are not being developed, the proxy simply passes the request through and lets the client interact with the real server. In exercise 2, we will build a memoization proxy on the famous Fibonacci problem, and we'll check out how many function calls we save with the lookup. If you extend this idea, you can use a proxy to memoize the response of expressive API calls and serve these calls without recalculating the results. Exercise 3 highlights 3 use cases. First, we may need to deal with JSON data that has a non-restricted structure. If we cannot make assumptions on the structure of a document, proxies come handy. Second, we can establish a logging layer including logs, warning messages, and errors using proxies. Third, if we have control over when we log errors, we can also use proxies to control client-side validation. If we combine the ideas of exercise 2 and exercise 3, we can use proxies to restrict access to endpoints based on user credentials. Obviously, this method doesn't save the server-side implementation, but proxies give you a convenient way to handle access rights.